Hello and welcome back. Welcome back to Section 10. Back in 2018, Section 10 got between code cycle changes between 2015 and 2018. Section 10 got completely revamped. For most part, it's been really good, very easy to understand. It's got better flow. It works very well. There have been a few cases of confusion, but let's just go through it. And there's been some additional rules added to Section 10 to help with clarification. So let's go through Section 10 here quickly, and it will not take long. So the first thing we're going to notice is Table 17 has been reused. And if you've been in the industry for as long as I've been in the industry, you'll remember what Table 17 was for. And I'm not even going to talk about it or say it because I don't want to create confusion. So Table 17 now is the integrity of an impedance grounding system shall be monitored and controlled as required by Table 17. So let's find Table 17. Let's go through here. There we go. So, use. The integrity shall be monitored and controlled as required by Table 17. Alarms required by Table 17 shall be clearly labeled as to their purpose, clearly indicate the status of the system and the persons monitoring it, continue signaling until the condition is corrected. So let's go to Table 17. Here we go. So Table 17 has the conditions for initiation of automatic alarm and de-energization columns. Then the rows are impedance grounded system configuration. Line to neutral loads are served 4-wire, all voltages and currents. So line to neutral loads are not served 3-wire systems 5 kV or less, and ground fault is limited to 10 amps or less. So, and then the second row is 5 kV or higher. Okay. So here's the column is ground fault on current carrying conductors, ground fault on conductor from source to impedance grounding device, and the last column is loss of continuity from the source through the impedance grounding device to the grounding conductive parts or equipment. So, and then we've got what is going to happen. So, depending on the condition is how it'll be. The table will tell you how to. It must be. This is what it must do. So on a ground fault in a current carrying conductor on a 5 kV or less, if it's scenario 1, alarm and de-energize system within the time rating of the impedance grounding device, or scenario 2, alarm and de-energize system within the time rating of the impedance grounding device. And then if we go to this second column, both are alarm and de-energize system within 48 hours if it's not corrected. And then the last column is alarm. And then again, it is alarm and de-energize system within 48 hours for scenario 2. So I think we have to go down and we have to look at what A and B is. So the note. On occurrence of a loss of continuity of the impedance grounding circuit from the system source through the impedance grounding device to the grounded non-current carrying conductive parts of the electrical system, the device monitoring the system can operate in one of two ways. It can continue to detect the ground fault of an ungrounded system, or it can no longer detect a ground fault on an ungrounded system. And then scenario B is much more dangerous. All right, so now let's just, we're going to leave this at this, and I think we're just going to have a quick little overview on what is What is impedance grounding? Many building systems and industrial processes require the advantages of both the ungrounded delta and the solidly grounded Y systems. These advantages are continuity of service, no tripping of the overcurrent device when a fault to ground occurs between one phase, line and ungrounded, conductor and ground. No damaging arcing or high fault currents flowing between the shorted phase and ground that could occur individuals working on the energized equipment when the fault occurs, and constant line-to-line voltage levels when single-phase loads are connected to the unbalanced three-phase system. Here's table 17 again, and basically a three-phase, so the resistor is actually placed in the grounding conductor. So what is impedance grounding? An impedance grounding device, also known as a neutral grounding device, consists of neutral grounding resistors, single-phase neutral grounding transformers, ground fault neutralizers, resonant and Peterson coil, three-phase zigzag transformers, or combination of these whose purpose is to decrease the level of ground fault current for safety, reduce arc flash, to reduce loss of production, and to mitigate equipment damage. Other benefits of the impedance grounding system are to limit the voltage rise of other phases so as to not to exceed the line-to-line voltage, and to stabilize the system voltage to ground both during normal operations and during phase to ground fault conditions. That's a little lesson on impedance grounding. We see very little of it. And here's an indication from a transformer. So this is a delta Y configuration of a transformer. All right. A new rule has been added. Well, it wasn't new. It's been re-added to Section 10. So the installation of bonding conductors. The bonding conductor shall be permitted to be spliced or tapped. Where one or more bonding conductors enter a box, all the conductors shall be in electrical contact with each other by one of the following means: securing all bonding conductors under bonding screws, or connecting all bonding conductors together with a solderless connector, so a wire nut. Where bonding conductor is run in the same raceway as other conductors to the circuit which is connected, it shall be insulated, except that an uninsulated bonding conductor shall be permitted to be used where the length of the raceway does not exceed 15 meters. And here is a bonding conductor. There's a wire connector, and there is two bond conductors, and a third bond conductor goes to the receptacle, and a fourth bond conductor goes to the bonding screw of the metallic box. Even plastic boxes have a strap that is metallic that has a bonding screw on it in Canada. Where circuit conductors are installed in a raceway, a separate bonding conductor, when required, shall be installed in the same raceway as circuit conductors. There's some parts of the code that talk about when we have to have a bonding conductor in a raceway. When it's PVC, and in some cases, even when it's EMT, when it's outdoors, we have to have a bonding conductor in a raceway outdoors, especially with EMT. Where a separate bonding conductor is run with single conductor cables, it shall follow the same route as the cables. And this talks about the copper bonding conductor shall, if number 6 or larger, and attached securely to the surface for which it is carried, be protected where exposed to mechanical damage, and if smaller than number 6, or if the installation does not come with the provisions for item A, be installed and protected in the same manner as the circuit conductor for a given installation. And sub-rule 7 is identical to the sub-rule 6, except it's aluminum instead of copper. So an Appendix B note, bonding conductor connection to electrical equipment. A bonding connection shall be made at every metallic and non-metallic outlet box for any fitting or device that requires connection to a bonding conductor. Here's the Appendix B note, and we'll talk about this once I read this. CSA 22.2 number 42 requires that receptacles be connected directly to a bonding conductor. For some other devices, such as switches, the bonding connection is permitted to be made via the mounting screws to the device enclosure. CSA 22.2 number 18.2 requires that the mounting screw termination point of a non-metallic device enclosure be electrically connected by a bonding means within that enclosure. Installers should consult the manufacturer's instructions for proper installation of the wiring devices. In Canada, we get a lot of products that come from the south, that come from the US, and especially switches. We often see switches come up with a bonding termination on it. Now, if the frame itself for the switch is metallic, then it would be considered to be bonded, because in Canada the metallic box is bonded, as well as there is a bonding strap which is bonded, which the switch would be screwed to. Just a little bit of a clarification on that. And again, here's the same picture again. So the receptacle requires it, regardless of whether or not, just regardless, the receptacles always gets bonded. Now the switch itself, this rule here, talks about the switch, not about the receptacle. So this rule here, this standard, the 22.2 number 42, requires that receptacles be connected directly to a bonding conductor. And then the switch does not if the mounting strap is metallic. So this is just the elimination of a rule. Bonding conductor connection to electrical equipment. So sub-rule 5 is now gone. A little bit of clarification to table 16. The size of the bonding jumper or bonding conductor. 3. The size of the field installed bonding conductor installed at other than service equipment shall not be less than determined in accordance with table 16 based on the ampere rating or setting of the overcurrent device protecting the ungrounded conductors, or the allowable ampacity of the largest ungrounded conductor for installations where the size of the circuit conductor is increased to compensate for voltage drop. Removal. And that's it for section 10. I will be also doing up a grounding and bonding addition all on its own as well, for services. It's somewhere we do see a lot of problems and a lot of misunderstandings. So I will be including a video on section 10 grounding and bonding for at the service and at the main panel.